Hello everyone, this is Yu. In this video, I will solve question 3 in homework 9. In this question, we have already know that x of t is a Poisson process with the function of like this is the probability of x of t equals to k equals to e to the power of minus lambda times k times lambda times t to the power of k divided by k factorial. And we also know that the expectation of x of t equals to lambda times t. And the variance of the Poisson distribution of x of t, it should be equals to expectation of x of t minus the expectation of x of t squared, and it's also equals to lambda times t. In this question, we need to prove or disprove the limit of t is closing to the infinity. X of t divided by t equals to lambda or not. According to the Chebyshev's equality, we can have this formula. The probability of x of t minus the expectation of x of t greater than epsilon should less than the expectation of x of t divided by the epsilon squared. Here we also substitute the x of t equals to the x of t minus the expectation of x of t to the formula. Then we can get this equation. The probability of x of t minus the expectation of x of t minus the expectation of x of t minus the expectation of x of t greater than epsilon should less than the variance of expectation of x divided by the epsilon squared. And because this part equals to 0, so this equation can be written like this. It's the probability of x of t minus the expectation of x of t greater than epsilon should less than the variance of expectation of x divided by the epsilon. And if I just divided t to the both sides, then we can get the probability of x of t divided by t minus the absolute expectation of x of t divided by t greater than epsilon divided by t less than the variance of x of t divided by t squared over epsilon squared divided by t. If we set the epsilon prime equals to epsilon divided by t, then the probability of x of t divided by t minus the expectation of x of t divided by t is greater than epsilon prime should less than the variance of expectation of x divided by the epsilon prime squared times t squared. And then if we set the limitation when t is closing to the infinity, the probability of x of t divided by t minus the expectation of x of t divided by t greater than the epsilon prime should less than the variance of expectation of x divided by the epsilon prime squared times t squared, which is equals to 0. So that means the limitation of the probability of p x t divided by t minus lambda greater than epsilon prime less than 0 when t is closing to the infinity should get the answer is limited when t is closing to the infinity. X t of t divided by t should equals to lambda, so that prove this function. So this is the whole process for the question 3 in homework 9. Thank you.